Yes, good morning, students. Am I audible? Yes, good morning, students. Am I audible?
Yes, sir, you are audible.
Yes, only 8 students are there. We'll wait for another 2 to 3 minutes and start the session with introduction to the different methods which is used to determination of particle size and its size distribution. Yes. Good morning, students. Am I audible?
Yes, sir. Good morning.
Yes, sir.
Yeah. Yeah. Now we'll move towards the next point. There are different methods which is used to determination of the micromeritics property. What are the content in this micromeritics? We have already discussed. Now, the first we'll go through the particle size and size determination. There are different methods which is used to determination of the size and size and shape of the particles. Then we also know the mean size distribution. Most of the pharmaceutical powders, the particle size distribution in uniformly dispersed. Uh, yes, I am correct. Most of the pharmaceutical powders are dispersed in uniform dispersion or polydispersion. Yes, students.
Polydispersion.
Yes, most of the pharmaceutical powders, the particles are distributed in polydispersed type, and then the powder particles are going to be distributed with respect to its number. It is called number distribution, and if the particle size and the powders are distributed with respect to its weight, it is called as the weight distribution of the particles. Then, generally, the size range of the powder particle is measured by using the diameter in set, and if the particles are asymmetric in set but asymmetric in nature, means the non-spherical in set, that time we are going to determine the different types of the diameters. Okay, and what are those different type of diameters already we have discussed in the last class. There are different type of the diameters like Stokes diameter, sieve diameter, projected diameter, then then mean moment diameter, then volume diameter. All these are the different type of the diameters is going to be measured when the particles are in unequal, in asymmetric in shape. That time we are going to measure its. That time we are going to measure its uh, equivalent diameters. And after the equivalent diameters, also we are going to discuss about the different type of the fundamental properties of the powder molecules. Because micromeritics, it is a branch of science and deals with study of different fundamental and derived properties for the powder sample. What are those fundamental properties? First one is the size, second one is the shape, third one is the its surface area, then particle volume, particle number. All these are the properties which comes under the fundamental type of the properties. And in derived properties, generally the different type of the densities like true density, bulk density, then granule density. All these are the densities which comes under the bulk density. Then afterwards, in derived properties, and angle of repose, then Carr compressibility index, then flow rate, then Hausner's ratio. All these are the property which comes under the derived properties for the powder sample. Then, generally, the powder uh, particle is perfectly spherical. If it is perfectly spherical, then uh, it is easy to express the particle size in diameter. And if the particles become a more asymmetric in nature, then it is difficult to express their size in its diameter. Under such conditions, we are going to measure the different type of the equivalent diameters. And what are those equivalent diameters? The first one is the surface diameter. Surface diameter is the diameter of the particle which is equal to the same surface area as that of a symmetric particle, is called as surface diameter. Volume diameter, the diameter of the particle which is equal to the same volume as that of a symmetric particle, is called as volume diameter. Projected diameter, the diameter of the particle or diameter of the sphere having the same observed area under the microscope as that of a symmetric particle, is called as projected diameter. And Stokes diameter, the diameter of the particle which describe as an equivalent sphere undergoes sedimentation at the same rate as the asymmetric particle is called as Stokes diameter. Sieve diameter, the diameter of the sphere having the same sieve aperture as the asymmetric particle is called as sieve diameter. And last one is the students, please wait. Projected area as that of the particle, which is called as projected diameter. And after this, all the diameters, then we'll discuss how the particle size is going to be distributed into the how the particle size is distributed when how the particle size is going to be distributed into the particular formulation. That part also we are going to determine with the help of the different techniques which is used for determination of the size and shape of the particle. Now, what are those size and shape of the particles? The first one is the first size. It is called as the first size. The first size of the particle is going to be determined by using sieving method.
Excuse me, sir.
Second one is yes, yes,
Sir, your screen
yes,
is not
students,
visible.
please, yes,
Screen
yes,
is not
please wait.
visible.
Yes, yes, please wait for 2 minutes. Okay. Then the method, the second method, it is called as microscopic method. In microscopic method, uh, with the help of microscopic method, also it is possible to determine the size of the particle. And next one is the sedimentation method. Sedimentation method is also used to determination of the size range of the particle. And in sedimentation method, generally we are using the Anderson pipette. We are using Anderson pipette, which is used for determination of the particle size and size distribution. And now here you have to remember one thing. Suppose if we are using, if we are using the microscopic method, then we are getting the particle size and size distribution with respect to the number of the particles. Means it is easy to determine the number distribution with the help of the microscopic method, which is used for determination of the particle. If we are using the sieve analysis method, in sieve analysis method, we are getting the particle size and size distribution with respect to the weight of the sample. With respect to the weight of the sample, we are going to determine the particle size and size distribution. Then already we know that if the particle size and size distribution of the particle with respect to the number, it is called as number distribution. And if the particle size and size distribution with respect to its weight, it is called as weight distribution of the particle. Generally, the particle size and size distribution is divided into two types. One is the weight distribution, and then second one is the number distribution of the particle. And then third method, if we are using the sedimentation method, in sedimentation method also uh, we are getting the particle size and size distribution with respect to the weight of the sample. Means weight distribution we are getting. See, one thing you have to clear in your mind, if we are using the sieve analysis method, then the weight distribution of the particle we are getting. If we are using the optical microscopic method, then the number distribution we are getting. if we are using the sedimentation method, then we are getting the if we are using the sedimentation method, in sedimentation method, we are getting the weight distribution of the particle. Yes, students. Now this point is clear now. Yes, isn't it? If we are using sieve analysis method, then what type of the distribution we are getting?
Weight distribution.
Weight
Yes,
distribution.
yes, very good. Weight distribution. And if we are using the sedimentation method, then
Weight distribution.
in sedimentation also weight distribution. And if we are using the sieve analysis method,
Number distribution.
sieve number. Yes, students. Sieve only if we are using the microscopic method, then we are getting the number distribution.
Number
If we are
distribution.
using, yes, because with the help of microscope, we are going to count the number of the particle only. But in case of sieve analysis method, we are going to use the weight of the particle. We are going to take the weight of the particle, and if we are going to take the weight of the particle, means it indicates that we are going to measure the weight of the particle, means the particle size and size distribution with respect to the weight of the sample. And in sedimentation also, we are going to measure the weight of the residue of the sample after the evaporation, and that residue we are going to take into the weight. That's why the particle size and size distribution also with respect to the weight of the sample. Yes, yes. Is this visible? Hello? Yes,
Yes, sir.
students? Yeah.
Please start the recording.
Yes, I have started already. Okay. Due to some electricity, that's I'm unable to share my screen. Okay, now it is okay. Uh, yeah, yeah. Is this visible?
Yes.
Yeah. Then then the different shape of the particle, the different shape of the particle in different shape of the particles are generally distributed in spherical shape particles, because when we have to observe under the microscope, then we'll get spherical particles, then rounded particles, then spongy type of the particles, then acicular type of the particle, or cubic type of the particles, or cylindric type of the particles. Now these are the different particle size and shape of the particular powder sample. Then the particle surface area. The particle surface area is going to be measured by using formula pi into d square, and the particle volume is measured with the help of pi into d cube by 6. This is a formula which is used for determination of particle volume. And afterwards, the powder characteristics. In a collection of powder, when we have to take the powder sample and you have to focus it under the microscope, then we will get the uh, polydispersed type, because all the pharmaceuticals are not distributed in uniform dispersion we are getting. Okay, this is about the dispersion of the powder sample. And then afterwards, with the help of this Edmondson equation which is used for determination of the average particle size, determination. And what is the that Edmondson equation? Edmondson equation, d mean indicate as the average particle size. Average particle size, which is equal to see here, summation of nd raised to p plus f divided by summation of ndf 1 by p. Here here n is, which is equal to number of particles in each size range. Size range means what? The particle size range which is distributed into 0 to 100 size range. Okay, 0 to 100 size range particles we are getting. And how the particle size range we are getting in between 0 to 100, like 0 to 10, then 10 to 20 micrometer size range particles, and 20 to 30, 30 to 40 micrometer size range, then 40 to 50 micrometer size range particles, then after 50 to 60 micrometer size range particles, then 60 to 70, 70 to 80, 80 to 90, 90 to 100. Now, these are the different size range of the particles. Then I will show you in the practical also how the particle size are going to be distributed into the different size range. Okay, then uh, D indicate as the diameter of the particle, which is given in the particular size range, and P it is related to the index, which is related to the size of individual particles, and F it is called as frequency, and D is raised to power 1. If it is 1 which is equal to length, 2 which is equal to 2 stands for if the P value 1 1 stands for P is which is equal to 2 stands for surface area. If which is P which is equal to 3 stands for volume. And again here, if the P value it is greater than 0, yes, yes students, hello,
Sir, your
yes,
voice
any
is
problem
breaking.
is there? My voice is breaking. Okay. Yes, am I audible clearly? Yes, am I audible clearly?
Yes, sir. Yes, sir.
Okay. Yes, students. Now, uh, the average particle size is based on that Edmondson equation which is used. That Edmondson equation which is equal to D mean which is equal to summation of ND P plus F divided by summation of F into 1 raised to P. Here, P stands for 1, which is equal to length. P which is equal to 2 stands for surface area. P which is equal to 3 stands for volume of the particle. And if the P value it is greater than 0, then it is called as arithmetic mean. If the P value which is equal to 0, then it is called as geometric mean diameter of the particle. If the P value is less than 0, then it is harmonic mean diameter of the particles. Here you have to remember for the GPAT point of view, P which is equal to 1. Yes. Now please tell me if P which is equal to 1, P is equal to 1 stands for
Length.
length. P which is equal to 2,
Area.
Surface area.
surface area. P which is equal to 3,
Volume.
Volume.
volume of the particles. Okay, and now here again based on the P value, if P is greater than 0, arithmetic, equal to 0, geometric, and less than 0, it is harmonic mean diameter. It is related to the P. And again F
F stands for what? F, which is equal to frequency index. Frequency index means what? How many particles are there? And again, the frequency F has values of 0. If it is 0, 0 stands for number, 1 stands for length, 2 stands for surface area, and 3 stands for volume or weight of the powder particles. Yes, students, now there is a difference between what? P and F. If P, which is equal to 1, which is length, P, which is equal to 2, stands for surface area, P, which is equal to 3, stands for volume of the particle. Frequency index F, which is equal to 0, it is number. If it is equal to 1, then it is length. If it is equal to 2, it is surface. If which is equal to 3, then volume or weight of the powder particles. Okay, then according to this frequency and frequency index and the index which is related to the size of the individual particle, again there are different type of the diameters we are going to measure for the particles. And what are those diameters? Now here you have to see in this column here P, which is equal to 1, and F, which is equal to 0. Yes, students, now tell me, if P, which is equal to 1, 1 stands for what?
Length.
Length of particle.
Length. And F, which is equal to 0?
Numbers.
Number.
Yes, number. Means which type of the diameter? Which type of diameter we are getting here? Length, number, diameter. Yes, is it clear now?
Yes, sir.
According to the frequency and according to the index of size of the individual particle, the different type of the distribution we are getting. And what are those different type of the distribution? The first one, if P, which is equal to 1, F, which is equal to 0, means length, number, diameter. P, which is equal to 2, F, which is equal to 0, then surface number, diameter. P, which is equal to 3, F, which is equal to 0, then volume, number, diameter. Now again, if P, which is equal to 1 and 1, P is 1 and F is 1, means, yes students, which type of the distribution we are getting?
Length.
Length.
Yes.
Diameter.
One it is, yes, very good. Length, diameter we are getting. If 1 and 2,
Length, surface diameter.
Length, surface,
Yes.
diameter.
Yes, length, surface, diameter. Yes, very good. And 1 and 3?
Length,
Length,
volume,
volume,
diameter.
diameter.
Length. Volume.
Length,
volume,
weight
diameter.
or length, volume, diameter. But most of the pharmaceutical powders, which type of the distribution we are getting here? Length, surface, diameter we are getting, because length, surface, it is important for the pharmaceutical powders. Okay, and when we are going to calculate this average surface area of the particle, that time we are going to measure their surface number, diameter for the particles. Now this is about the different type of the distribution for the powder sample into the powder sample and its size distribution. Yes students, now average size of the particle is going to be measured by using which formula? Yes, now please tell me formula. D mean, which is equal to summation of ND plus F divided by summation of ND F bracket close 1 by P. And this equation it is called as Edmondson equation for the determination of average size range of the particles. Now this table is very important for GPAT point of view. You have to remember this table because when P which is equal to 1, then F which is equal to 0, P which is equal to 2, F which is equal to 1, P which is equal to 3, F which is equal to 2, and F which is equal to 3 and P which is equal to 3 means what? Okay. And again, on the basis of P value, again arithmetic mean diameter, geometric mean diameter, and harmonic mean diameter of the particles. Hey students, what do you mean by arithmetic mean diameter? Please tell me. Arithmetic mean diameter means what?
P less than greater. Please.
Yes.
P is greater than 0.
P. Yes, P is greater than 0 or less than 0?
Greater than
Less
0.
than. Greater than. P is
Now
greater than
here,
0.
P is greater than 0 arithmetic and P is equal to 0 geometric and P is less than 0 then harmonic
Harmonic.
mean diameter of the particle. Okay, please you have to remember this chart also. P which is equal to 1 and F which is equal to 0, P which is equal to 2, F which is equal to 0, P which is equal to 3, F which is equal to 0, P which is equal to 1 and F which is equal to 1, 1, 2, 1, 3. Okay. Yes. Then now we'll move towards the arithmetic mean diameter of the particles. What are the different types of arithmetic mean diameter of the particles? Yes, students, please tell me what do you mean by arithmetic mean diameter? Arithmetic mean diameter means what?
P is greater than 0.
Greater than 0.
If the p value is greater than 0, that type of the mean, it is called as arithmetic mean diameter of the particle. Okay. Then it is the sum of particle sizes which is divided by the number of particles. For polydisperse powder, arithmetic mean is expressed by considering it a collection of uniform particles. Okay, for example, if two particles of 2 micrometer size range and 4 particles are in and second particles 4 micrometer size range particles can here can we replaced by 2 micrometer size range particles with 3 micrometer size range particles. That time the method is used for expressing the mean number of the particle and length of the particle, but the variation in the mean volume or surface area of the particles, that is different means value are obtained, which is based on the length and surface area or volume, etc. Then there are different types of arithmetic mean diameters we are going to measure here. First one, it is called as length number diameter. Length number diameter, which is equal to summation of ND divided by summation of N. Now here N, which is equal to the number of the particles. Okay. And D, it is called as the equivalent diameter. If we have to multiply N and D, number of particles with respect to the D, and divided by the total number of the particles, how many number of the particles are there, and that type of the diameter, it is called as length number mean diameter. And afterwards, second arithmetic mean diameter is average surface diameter. Average surface diameter, which is equal to square root of summation of ND square divided by summation of N. Average surface diameter, that is surface number surface number mean refers to the particle having average surface area. And third one is the mean volume diameter. Mean volume diameter is the volume number mean. It is referred to the particles having average weight. It is related to inversely to the number of the particles per gram of the material. Therefore, the number of the particle which is determined by using formula n, which is equal to 6 by pi into dvn cube into rho. Here pi is the constant, d is the average diameter, and v is the volume of the particle, and n is the number of the particles and rho is the density of the particle. And again, put the value into the next formula like dv, d is the diameter, v is the volume, and volume number diameter, which is equal to summation of n d cube by summation of n. This is the formula which is used for calculation of mean volume diameter. And the next diameter, it is called as the mean volume surface diameter or weight surface weighted mean diameter. And surface weighted mean diameter, which is equal to summation of nd cube divided by summation of nd square. Okay, here there are different four types of arithmetic mean diameter. One is the length number mean diameter. Second one is the average surface diameter. Third one is the mean volume diameter, and next one is the mean volume surface diameter or the surface weighted mean diameter. Okay. Now this part I will again in detail I will take this part in the practical, because one of the practical which is based on this arithmetic mean diameter of the particle. The particle size and size distribution with respect to the sieve size analysis method. On the basis of sieve size analysis method, when we are using the sieve analysis method, which is used for determination of the particle size, then we are going to measure the different types of arithmetic mean diameters. And what are those arithmetic mean diameter? First one is the length number mean diameter. Second one is the average surface diameter. Then third one is the mean volume diameter, and next one is the mean volume surface diameter or mean volume weight diameter for the particle. Now all these are the diameters we are going to measure in the practical also, when we are doing the practical, because three practicals which is based on this Micromeritics chapter. One, the particle size and size distribution by using sieve analysis method. Second one, the particle size and size distribution by using sedimentation method. And third one, the particle size and size analysis by using optical microscopic method. All these methods we are using. And again, the weight moment volume or volume weighted mean diameter, which is also going to be calculated by using formula summation of nd raised to 4 divided by summation of nd cube. Now these are the different types of arithmetic mean diameter of the particles. And what are those different arithmetic mean diameters? Yes, students, first one is the length number diameter. Here you have to note down the formula for length number mean diameter. Length number mean diameter, which is equal to summation of nd divided by summation of n. Second one is the average surface diameter. Average surface diameter, which is equal to summation of square root of nd square divided by summation of n. Mean volume diameter, which is equal to square root of summation of nd cube by summation of n. Mean volume surface diameter or mean volume surface weight diameter, which is equal to summation of nd cube divided by summation of nd square. and weight moment or volume weighted mean diameter, which is equal to summation of nd raised to 4 divided by summation of nd cube. All these are the five formula which is used for calculation of different types of arithmetic mean diameter of the particles. Yes, students, now please tell me what are the different types of arithmetic mean diameters?
Length, number, diameter.
Very good. One is the length, number, diameter. Second one,
Average surface diameter.
average surface diameter. Third one,
Mean volume diameter.
Mean volume
mean
diameter.
volume diameter. Very good. Next one,
Mean
Mean
volume
volume
surface
surface
diameter.
diameter.
yes, mean volume surface diameter or surface weighted mean diameter. Then last one is the weight moment or weight weighted mean diameter. Okay, volume weighted mean diameter. Then we are using summation of nd raised to 4 divided by summation of nd cube formula we are using. Okay, if we are using the sieve analysis method, then we are going to calculate the different type of geometric mean diameter of the particles. And if we are using the optical microscopic method, then also it is possible to determine the different types of arithmetic mean diameter of the particles. Okay, then next mean diameter, it is called as geometric mean diameter. A student, geometric mean diameter means what? What do you mean
P
by
is equal
geometric mean
to
diameter? Yes, P which is equal to 0. If the P value which is
0.
equal to, yes. What do you mean by P? P stands for what?
Particle index.
Yes. Very good. Particle index of individual particles. Okay. Particle index for the individual particles. P which is equal to 0. Yes. It is called as geometric mean diameter. Then already we know that P is the particle index. Then we are going to measure the individual particle diameter. Okay. The advantage of this geometric mean over the arithmetic mean is that only one value of geometric mean is obtained where one considers length or surface area or volume of the particles. Okay, then the geometric mean diameter of the particles can be expressed by using formula d geometric, which is equal to n into in square bracket d1 diameter of first particle into diameter of second particle into diameter of third particle up to diameter of n number of the particles. Put the value into this formula, then we are getting the geometric mean diameter. Okay, and again you have to convert this formula into the log. You have to convert this formula into the logarithm form. Then we'll get the log of d geometric, which is equal to summation of n stands for what? Students, n stands for,
Number of particles.
yes,
Number of
number of
particles.
the particles, and d stands for,
Diameter.
yes, means here you have to take the number of particles into log of d, the total addition of this log d or total multiplication of this log d value up to n, you have to take it, then divided by how many number of the particles you have to count it. Okay, suppose here the total 15 number of the particles are there, then first you have to multiply particle 1 to particle 15, then divided by how many number of the particles are there, total number 15. Okay, put the value into this formula, then we will get the log geometric mean diameter. Okay, and again at the end you have to convert this value into the this log d value into the, if you have to take the anti-log of this one, then we'll get the average particle size range in micrometer size range, and that is equal to your geometric mean diameter of the particles. Okay, now also another one practical which is based on this geometric mean also we'll discuss in the practical session. After the geometric mean diameter of the particle, then we'll move towards the harmonic mean diameter of the particle. And harmonic mean diameter of the particle rarely we are using in the pharmaceutical calculations. Mostly we are using two types of the diameters. One is the harmonic mean diameter, and then second one, it is called as the geometric mean diameter of the particles. Yes, students, now please you tell me what are the different types of the arithmetic mean diameters. Yes, what are the different types of arithmetic mean diameters?
Length, number,
Length,
diameter,
length
surface
number
area,
mean
Okay.
average surface diameter, mean volume
Yeah.
diameter,
mean volume diameter,
Volume
surface diameter.
diameter.
volume, surface area,
Okay,
diameter.
good. Yes, good. And how to calculate the geometric mean diameter? Geometric mean diameter of the particle.
T is equal to n under root d1
Yes.
d2 d3 up to the dn.
Yes. Okay. And now convert this formula into the log form. That is a log of d geometric, which is equal to in bracket n into log d divided by summation of n. Okay. This is a formula which is used for calculation of the average diameter of the particles. Then afterwards, we use next part is the harmonic mean diameter. Harmonic mean diameter particles were rarely we are using in the pharmaceutical calculations, but mostly the powder particles are distributed into the polydispersed type of the dispersion. Okay, then afterwards, next point, the particle volume and particle number. Yes, students. Now up to this point, it is clear now, isn't it? Have you understood this point? Different type of the arithmetic mean diameter, then geometric mean diameter, and harmonic mean diameter for the particles. Yes, it is clear. Yes, students. What are those different types of the diameters which is based on arithmetic and which is based on p value and f value? Yes, isn't it? Which equation it is used for determination of average particle number, particle size? Yes, student.
Edmondson equation.
Yes, Edmondson equation which is used for
Edmondson
determination of, yes, average number of the particle. What is the equation?
d mean is equal to I summation of nd p plus
Yes.
f upon summation of ndf I raised to 1 upon p.
Yes. Okay. And n which is equal to number, d which is equal to
Diameter.
diameter, p which is equal to
Particle index.
index, and f which is equal to frequency. Okay. Because in micromeritics we are going to measure the different types of the diameters. You have to remember the different type of the diameters. Okay. And if the particles, generally the particle size and size distribution is measured in diameter, and if the particles are asymmetric in nature, then we are going to express the different type of the diameters for the asymmetric type of the particles. And what are those diameters? Hey students, first one is the surface diameter, volume diameter, projected diameter, yes, Stokes diameter,
Stokes
sieve
diameter,
diameter,
sieve diameter,
Volume
volume
and
surface
volume
diameter.
yes. Okay, apart from this 6 diameter, again we have discussed 3 types of the diameters, which is based on Emerson equation, right? Based on p value, what are the different type of the diameters? Arithmetic mean
mean
diameter.
diameter,
Length number
geometric
diameter.
diameter, harmonic diameter.
Yes. Yes, arithmetic, geometric, and harmonic. Again, arithmetic mean diameters are 5 types, right?
4 types, sir.
What are those 5 types?
length, number, diameter,
Okay.
average surface diameter,
Average surface diameter.
mean volume
Next,
diameter,
mean volume diameter. Next,
mean volume surface
Mean
diameter,
mean volume surface diameter. And last one is the
weight, moment, or volume
yes,
weighted.
weight, movement, or volume weighted mean diameter. These are the different types of the arithmetic mean diameters. Okay. Now next question, please tell me, if P is greater than 0, that type of the diameters are called as? P is greater than 0.
arithmetic
Arithmetic diameter.
arithmetic diameter.
If the P value it is less than 0,
Harmonic
Harmonic
diameter,
diameter.
Harmonic diameter.
and P which is equal to 0.
geometric diameter,
Geometric.
Okay, very good. Yes, very good. Okay, next question. Okay. If the particle size and size distribution for most of the pharmaceutical powders are
Polydispersed.
polydispersed,
very good, polydispersed type of the dispersion. Very good. Okay, what do you mean by monodispersion of the particles?
particle
Same
size,
diameter particles, uniform size.
Yes, if the particle size are in same diameters, and that type of the distribution it is called as monodispersed type of the dispersion. If the particle size and diameter of the particles are different, and that type of the diameters are called as the polydispersed type of the dispersion. Okay, very good. Now, next question. Now, please tell me, what are the different fundamental properties for the powders? What are the different fundamental properties? First one.
Particle number, particle size, angle of
Yes.
repose.
No, angle of repose. Angle of repose comes under the derived properties. First one is the particle size and size distribution.
shape,
Particle shape and particle shape and its surface area, particle number, particle volume. These are the fundamental properties for the powder. Yes, isn't it? Hey students, have you understood this point? Fundamental and derived properties. Micromeretics is a branch of science in deals with study of the small size particles and also deals with the different fundamental and derived properties for the powder sample. What are those fundamental properties? First one is the size of the particle. Second one is the size and its size distribution, shape and surface area, volume of the particle, and number of the particles. These are the different fundamental properties for the powder sample. And in derived properties, what are those derived properties? First one, densities, different type of the densities like tap density, bulk density, then true density, then granule density. These all are the densities comes under the derived properties. Then next property, angle of repose. Angle of repose also comes under the derived properties. Next one, flow rate. Flow rate also comes under the derived properties. The next one is the Car's index and Hausner's ratio. All these are the property which comes under the derived properties for the powder sample. Yes, students, isn't it? Now, different types of fundamental properties and different type of the derived properties for the powder sample. Okay, now please tell me what do you mean by micromeritics? Yes. Micromeritics means what?
Study
Study
of
of?
small
It is the
particles.
science and technology of small particles.
Yes, it is a science and technology of the small particles. Then again, micromeritics, it is defined as the study of fundamental and derived properties for the powder sample. Okay, now in next class we are going to discussion on the different types of the methods which is used for determination of the particle size and size distribution. Okay, now here another one point which is remaining, particle volume and particle number. This point also we'll discuss in the next class, how to determine the particle volume and particle number for the individual particles. Okay, now here I'll stop the session over here.